A Unity 2D platformer that feels good is 90% just three things: crisp movement, coyote-time, and jump buffering. In the next 12 minutes we build the whole controller, in C#, line by line. One quick, honest heads up before the code. The finished script is free on my site, link below. It is also one of 50+ snippets in my gamedev starter kit, $19, with the Unity cheat sheet and a 30-day roadmap. Totally optional. Now, let's build the controller. Here is the thing nobody tells you. Most Unity 2D movement tutorials give you a controller that technically works, but feels awful. The character stops on a dime. Jumps miss by a single frame. It feels stiff, and you cannot say why. Great platformer feel comes from three small tricks, and they are the whole difference. Crisp movement: you set the velocity directly, so the character responds instantly. Coyote-time: a tiny window that still lets you jump just after you walk off a ledge. And jump buffering: you catch a jump the player pressed a hair too early, right before they land. That is it. Learn these three, and your Unity 2D platformer stops feeling like a physics demo and starts feeling like a real game. We will build the base first, then layer each trick on top. Before any code, the character needs the right components. This part is hands-on in the Unity editor, so I will show you clean component diagrams. The exact click-by-click is in the free written guide on screen. Select your player sprite in the scene. Add a Rigidbody 2D, that is what lets Unity's physics move it. Set its gravity scale to about 4, so falls feel weighty instead of floaty. And turn on freeze rotation Z, or your character will tip over and spin the first time it touches the ground. Add a box collider 2D so it has a body that collides with the world. Then add one empty child object, called ground check, and drag it down to the character's feet. That little point is how we will ask, later, am I standing on the ground? That is the whole setup. One rigid body, one collider, one ground check point. Now we can write the script. Let's start with horizontal movement. Create a new C# script called player movement, and attach it to the character. Here is the base. At the top, two public fields, move speed, and a reference to the Rigidbody 2D. Public means they show up in the inspector, so you can tune them without touching code. In start, we grab the Rigidbody with getComponent, once, and cache it. The real work is in update, which runs every rendered frame. Line 1, input.getAxisRaw, horizontal. That reads your left and right keys and hands back -1, 0, or 1. GetAxisRaw with no smoothing is what gives you that instant, snappy response, no mushy ramp-up. Then the important line. We set rb.linearVelocity to a new vector 2, the x is move input times move speed, and we keep the existing y untouched. Setting the velocity directly, every frame, is the crisp movement trick. The character moves the instant you press, and stops the instant you release. One quick note on Unity versions. In Unity 6, the property is linearVelocity. If you are on Unity 2022 or older, it is just called velocity. Swap that one word and everything else is identical. Now, can the character jump? Only if it is on the ground, so we need a ground check. This is where that ground check point at the feet earns its keep. Add 3 fields. A transform for the ground check point, a small check radius, about 0.2, and a layer mask called ground layer. In the inspector you drag the ground check child onto the transform, and set ground layer to whatever layer your platforms live on. Then, every frame, one line. Is grounded equals physics 2D.overlap circle, at the ground check position, with our radius, filtered to the ground layer. Overlap circle draws a tiny invisible circle at the feet and asks, is anything on the ground layer touching it? If yes, is grounded is true. Why a separate point and a layer mask? Because you want to test only the feet, and only against real ground, not walls, not enemies, not the player's own collider. Get this check right and every jump mechanic after it just works. Get it wrong, and nothing else will. Now the jump itself, and it is genuinely 2 lines. In update, if input.getButtonDown, jump, and isGrounded is true, we set the velocity's y to jump force. Notice we keep the existing x velocity and only replace the y. That way you keep your horizontal speed through the jump, you launch in an arc, not straight up. Jump force is a public field, around 16, so you can tune the height live in the inspector. GetButtonDown fires exactly once, on the frame you press, not while you hold. So 1 press is 1 jump. Press play, and you can already run and jump around your level. But here is the problem. This jump only fires if isGrounded is true on the exact frame you press. Walk off a ledge and press a frame later, nothing. Press a frame before you land, nothing. That single frame strictness is what makes movement feel stiff. The next 2 tricks fix exactly that. First fix, coyote-time. Named after the cartoon coyote who runs off a cliff and hangs in the air for a beat before falling. We give the player that same forgiving beat. The idea is simple. Instead of asking are you grounded right now, we keep a little timer. Add a coyote-time field, 0.1, so 1/10 of a second, and a coyote counter. Every frame, 1 line does the work. If isGrounded, set coyote counter back to the full coyote time. Otherwise, subtract time.delta time, count it down. So the counter is full while you stand on ground, and starts ticking down the instant you leave it. Now the jump asks coyote counter greater than 0, instead of isGrounded. For 1/10 of a second after you walk off a ledge, the counter is still positive, so the jump still fires. To the player it feels like the game just read their mind. In reality, you gave them a 100 millisecond grace window. It is one of the highest impact lines you will ever write for game feel. Second fix, jump buffering. This one solves the opposite problem. The player mashes jump a hair before they hit the ground, that press lands on empty air, and nothing happens. It feels like the game dropped their input. Same trick, mirrored. Add a jump buffer time, again 0.1, and a jump buffer counter. When input.getButtonDown fires, we do not jump immediately. We set jump buffer counter to the full buffer time. Otherwise, every frame, we count it down with time.delta time. So a press is remembered for 1/10 of a second. Now the jump condition checks both counters together, jump buffer counter greater than 0, and coyote counter greater than 0. When both are alive, we jump, then 0 both counters so it fires only once. Read that condition again, because it is the heart of good feel. A jump happens when a recent press meets a recent grounding. Press slightly early, and the buffer waits for the ground. Leave the ledge slightly late, and coyote time covers you. Together, they make a Unity 2D platformer feel fair. One last layer, variable jump height. Right now every jump is the same height, whether you tap or hold. Real platformers let a quick tap make a small hop, and a long hold make a full leap. The fix is one more check. If input.getButtonUp fires, the player let go of jump, and the character is still moving up, we cut the upward velocity. We set the y to itself times a jump cut multiplier, around 0.5. Half the remaining rise, gone, the instant they release. So a short tap releases early, the velocity gets cut early, and the hop is small. Hold it, and the full velocity carries you to the peak. Same jump force, but now the height answers to how long the button is held. That is the difference between a floaty jump and one that feels precise. For tiny additions, ground check, coyote time, jump buffering, variable height, and your controller now feels genuinely good. And that is a complete Unity 2D platformer controller. Crisp direct movement, a reliable ground check, coyote time, jump buffering, and variable jump height, every line explained, nothing you cannot modify. Here is your next move. Grab the full script free from the link below, drop it on your player, and tune the numbers until it feels right. Your next watch is lined up, building a level with the Unity tile map, so your character has a real world to run through. Or make your first full game, Flappy Bird in Unity, start to finish. And if you want the whole toolkit, the Game Dev Starter Kit has this script plus 50 more, with the Unity cheat sheet. Subscribe for more Unity builds. Now go make it feel good. See you in the next one.